إلا صرت في مانع في جوز دوس عندي خش.
Hello. Hello students. Today we are going to do the ninth chapter from a science textbook, which is carbon compounds. So carbon compounds are mainly divided into two groups, saturated and unsaturated hydrocarbons. So alkanes come under saturated hydrocarbons and alkenes and alkynes come under unsaturated hydrocarbons. Saturated hydrocarbons contain a single bond, while unsaturated hydrocarbons they contain a double or triple bond. So how are these bonds exactly formed? So we'll try to understand this through the electronic configuration of carbon atom. So carbon, the atomic number of carbon is 6. So its electronic configuration, as we have studied in the second chapter, it is written as 2 and 4. So there are 4 electrons in the outer shell. So carbon has 4 electrons, 1, 2, 3, 4. So it can make 4 bonds with the other atoms. So hydrogen is the most reactive as it has only 1 electron. So hydrogen shares its electron. So 4 hydrogens share their 1 electron with carbon and they form a bond. 2 electron forms a bond. And that's how the compound is formed, CH4. 1 carbon atom with 4 hydrogen atoms, it forms CH4. So the carbon atom is very reactive as it has only 4 electrons in the outer orbit. So it forms various molecules or compounds with the hydrogen atom, and these are classified under alkanes, alkenes and alkynes. So we'll see what are these groups exactly. So in alkanes, carbon form only a single bond with the hydrogen atoms, like in CH4. So the formula is CnH2n plus 2. So we have to put the number of carbon atoms in the place of n. So if I put n is equal to 1, so the formula will be C1H2 into 1 plus 2. 2 plus 2, 4. So C, 1 we don't write, so the formula for the first carbon compound is CH4, which is nothing but the methane. If we put N is equal to 2, so it will become C2H4 plus 2, 6. So it will be the second compound of the alkane family, which is ethane. So we'll write all the compounds of the alkane family one by one. So this is the alkane family. First compound is methane. The second compound is ethane. The third compound contains 3 carbon atoms, so it is called propane. And the list continues. So methane is CH4, ethane is C2H6. For propane, we'll put the carbon atoms is equal to 3. So N will be equal to 3. Yeah. So the molecular formula of ethane is C2H6. Now if we put for propane, if we put 3 is equal to N, then the formula becomes C3H6 plus 2, H8. Now it's easy. For butane we have to put 4. So it's C4H10. For pentane the carbon atoms are 5. So C5H12. For hexane we have to put 6 in the place of N. So it will be C6H14. For heptane, 7 carbon atoms, C7H16. For octane, 8 carbon atoms, C8H18. For nonane, 9 carbon atoms, C9H20. And for decane, there are 10 carbon atoms. So if we put 10 in this formula, we get C10 and H22. So these are the 10 members of the alkane family. You have to just remember this formula CnH2n plus 2, and you can deduce all the 10 members of that alkane family. So how does the member actually look? So CH4, I showed you, it looks like this. 4 hydrogen atoms around a single carbon atoms. Now if we take for example C5H10, so how will you draw its molecule? So C5, so first we will draw 5 carbon atoms. Then as they are alkanes, we will draw a single bond around each. And we know that carbon has 4 bonds because it has 4 electrons in the outer orbit. So 4 bonds with each carbon atom. See, 1, 2, 3, 4 for first carbon atom, 1, 2, 3, 4 for second carbon atom. So each carbon should have 4 bonds. Now we'll just write hydrogen after every bond. And now our pentane looks something like this. C5H12. You can count the number of hydrogen atom is 12 and C is 5. So this is how we write a pentane. So if in exam it comes that write the members of the alkane family and draw their structure. So it is very simple. You have to draw like this. Now let's come to the alkene family. So alkene family has double bonds and the formula is CnH2n. So it is alkene. So the ending will be ENE instead of ANE. So what will be the first compound? It is methane instead of methane. It is methane. The second member will be ethene. The third member will be propene. The fourth member will be butene. For alkane, it is pentane. So for alkene, it will be pentene. Sixth member will be hexene, heptene, octene. Ninth member is nonene and decene. So it's very easy to remember these names. For alkane, the ending is ANE. For alkenes, the ending is ENE. And for alkynes, the ending is YNE. Okay, got it. So we'll write the chemical formula for all the members of alkene family now. So what is the formula? CnH2n. So the number of carbon atoms is n and H is 2n, the double. So the first member, if we put n is equal to 1, so what will be its chemical formula? C1 and H2. So CH2. Okay. Then for ethene, if we put n is equal to 2, C2H4. So for propene, it is C3H6. For butene, we have to put n is equal to 4. So 2 into 4 is 8. C4H8. For pentene, it is C5H10. Hexene, C6H12. You can see it's very easy to write the molecular formula if we remember the main formula. For heptene, it is C7H14. Octene, C8H16. Nonene, C9H18. And decene, C10H20. So these were the 10 members of the alkene family. Now how to write their structural formula? So as we have seen for the alkane family, we can see it for the alkene family. So it is possible to write the structural formula from ethene because a double bond is formed between 2 carbon atoms. So we minimum need 2 carbon atoms. So there is no structural formula for methane. So we can say that methane doesn't exist. So the alkene family starts from ethene. So we can write the structural formula for ethene. So 2 carbon atoms and there are 4 hydrogen atoms. So first we'll give 4 electrons of carbon and then 4 hydrogen atoms have each 1 electrons. But there is double bond between. So if I write these electrons here, so these 2 electrons will form a bond. These 2 electrons will form a bond. We need 2 electrons to form a bond. Now hydrogen comes from here, 1 hydrogen comes here, 3rd hydrogen, 4th hydrogen. So each share their 1 electron and hence here a bond is formed, here a bond is formed, here a bond is formed and here a bond is formed. So this is the structural formula for ethene, C2H4. Now I will show for pentene and then you guys can try for the rest of the alkene family. It's very easy to write the structural formulas. So we see it for pentene. So first of all there are 5 carbon atoms. So we write 5 carbon atoms. 1, 2, 3, 4, 5. Then it is pentene, alkene, double bond. So we have to give a double bond somewhere. You can give anywhere, here. It's your choice. Then we have to just fill the valencies of carbon. We have to give 4 hydrogen atoms or 4 bonds to each of the carbon. Now first we'll look at this carbon. It has already 2. So it needs only 2 hydrogen. Now we look at this carbon atom. It has already 3 bonds. 1, 2, 3. So it only needs 1 because the carbon can make only 4 bonds. Now look at this carbon atom. It has already 2 bonds. So it needs 2 hydrogen. Now look at this carbon atom. It also needs 2 hydrogen. This carbon atom. It has 1 bond. So it needs 3 hydrogen. 1, 2, 3. So this is the structural formula for pentene. Okay, got it? Now you can try for the rest of the alkenes. It's easy. Then if we go to alkynes, so the formula is CnH2n minus 2. So as I told you, the ending is YNE. So here also methane doesn't exist because we have to create triple bond between 2 carbon atoms. So the first member is ethane, the third member is propyne, fourth member is butane, and the fifth member, sixth member, the rest of the members up to dekyne you can try. So we'll write their chemical formulas by using this general formula CnH2n minus 2. So if we put 1 here, we can't put 1 because methane doesn't exist. So for ethane there are 2 carbon atoms. So if we put 2 here, so it becomes C2H2n minus 2. So it's 4 minus 2 H2. Okay. Now for propyne we put 3 C3 and H4. For butane we put 4 C4, 4 into 2 8, 8 minus 2 6. Okay. So you can try for the rest of the members to write the chemical formula for the alkyne family. Now I will show you how is the structural formula. So first we'll write for ethane. So how many carbon atoms are there? 2. So we'll write 2 carbon atoms. We have to give a triple bond, at least 1 triple bond. So we have 2 carbon atoms. So there will be only 1 triple bond. Now how many valencies are left? We know there are 4 valencies. So carbon has made 3 bonds. Now it can make only 1 bond. So 1 bond H. It also has 3 bonds. It can make 1 bond H. So this is the structural formula for ethane C2H2. Okay. Then let's try it for butane. So first step is always you write the number of carbon atoms in one line. So C4, we write 4 carbon atoms and it is butane, alkyne. So there will be 1 triple bond. So we can write anywhere. I'll write it in the middle. Okay. And the rest will be single bonds. So now this carbon atom has only 1 bond. So it will make 3 other bonds to make 4 bonds. This carbon atom 1, 2, 3, 4. It already has 4 bonds. It can't make any other bond. This carbon atoms 1, 2, 3, 4. It already has 4 bonds. Its valencies are satisfied. This carbon atom, it has only 1 bond. So it will need more 3 bonds. So 4 valencies are satisfied. And this is the structural formula for butane. So you can try for pentane, hexane, and let me know in the comment section how you find this video and try the next members of the alkyne family. Alright, names for some of the chemical formulas we have written here, the carbon compounds. Now we'll try to write their IUPAC nomenclature. So the first one is this CH3, CH which is linked to OH and CH3. So first of all, the first step is we have to count the number of carbon atoms in any group. So here there are 1, 2, 3. 3 carbon atoms, and we know that the alkane for 3 carbon atoms is propane. And we have studied that when OH is added, there is ending OL. Okay, so this is propane with OH. So the name will be propanol. But in IUPAC names, we have to mention where the OH is attached. So first of all, we have to number the carbon atoms. So this is the first carbon atom, this is the second, and this is third. You don't have to number them in the exam. I am just writing for your information. So this is the second carbon atom. So the name of these compound will be propan-2-ol. So we have to also mention the number where the OH or the group is attached. So the name will be propan-2-ol. Okay, propan because it has 3 carbon atoms, so propane. It has a OH, therefore the ending OL. You have to learn these endings for all the groups like OH, CHO, for all the additional prefixes, suffixes. You have to learn these endings. Then you can solve this IUPAC nomenclature easily. You can write their IUPAC names. So 2 we have written because OH is attached to the second carbon. So let's go to the second one. So first of all, count the number of carbon atoms. 1, 2, 3, 4, 5. So for 5 carbon atoms, what is the name of the alkane member? Pentane. Now we have to see what is additional in this chain except the carbon and hydrogen. So we see here one halogen, which is chlorine, and chlorine is attached to the 4th carbon. And we know that whenever chlorine or bromine or iodine is attached, we call it as bromoethane, bromopropane. So it is 1, 2, 3, 4, 5, pentane, and chlorine is attached. So we will call it chloropentane. But we have to also mention to which carbon it is linked, to which carbon the chlorine is attached. So we can mention 4 chloropentane. Okay, 4 chloropentane. And you have to write this whole name as a one name without any comma, dash and space. You have to just give one dash between the numbers. So whenever numbers come, you can give a dash, but there has to be no space between chloro and pentane. You have to write it as one word. Okay? So let's see the third compound. First we'll count the number of carbon atoms. 1, 2, 3, 4, 5. So these compound also have 5 carbon atoms. So we know for 5 carbon atoms it is pentane. Now we have to see what is additional. So we have to see what is additional outside this rectangle. So we see a O, and this is nothing but CO, ketone. It is the ketone group and the ending is ONE. So it has 5 carbon atoms. So it is pentane and it is a ketone. So therefore we add the ending pentanone. Okay, so the name will be pentanone. Now O is attached to second carbon. So we will write 2. Pentane 2-O. It is a pentane, no doubt, but ketone is attached to second carbon, therefore pentane 2-O. Okay, so let's move on to the fourth one. So we'll count the number of carbon atoms here. So there are 1, 2, 3. So corresponding to 3 carbon atoms, we have propane. Now you have to see what is this compound. This is a whole separate compound, CHO. So CHO is aldehyde with ending AL. So this is 3 carbon atoms, which is propane, and if we add the ending AL, so propane becomes propanol, and this is always attached to the first carbon. So now I have numbered it as 1, 2, 3, but we can also start from here. 1, 2, 3. So we don't have to mention the number here because the COH group will always be at the start or at the end of the structure. So we can just write it as propanol, or if we take this as the third carbon or first carbon, we can also write propan 1R. But no need to write the number because it is always at the start or end. So this is the appropriate answer propanol. Okay. So the fifth one, we'll see how many carbon atoms are there. 1, 2, 3. Now here again, this is the whole group. Okay. So COOH, which is the carboxylic acid group. The ending is oic acid. Now we'll count the carbon. 3 carbons. So it is propane. And the ending is oic acid. Therefore it will become propanoic acid. And same like aldehyde, it is also present either at this end or either at this end. So it is always present at the starting or ending. Therefore we don't have to mention the number. So we can directly write propanoic acid. Okay. You have to just identify the additional group and we have to write its ending or the suffix, we can say, and then the name is formed. Then this compound has 3 carbon atoms. 1, 2, 3. So first of all, 3 carbon atoms, propane. Then what we see additional is this NH2. What is NH2? Amine group. Okay. So for amine, we generally add a prefix. We start it with amino. So 3 carbon atoms, propane and amino. But at what position it is? It is attached to second carbon. So 2 amino. 2 amino and 3 carbon atoms. So propane. 2 amino propane. But if this amino group was attached at the first carbon here, and remember the bonds are always with the carbon atom, so you have to always write the bond with the carbon atom, not the hydrogen. So if I add NH2 here, okay, so it will be propane, but the NH2 is attached to first carbon. So it will be 1 amino propane. Okay, understood? So if it was attached here and we have counted as 1, 2, 3, then it would be 3 amino propane. So the number changes according to the group. So these groups are attached to which carbon of that family or that compound. We have to see the chain that where the group is attached, and we have to add that number in the IUPAC name. So this was the way to write the IUPAC name. I hope you understand it. Thank you.